10.2 diffraction of light through a single slit. We did double slit, now we do the single slit. For single slit, we have a maximum, central maximum, very bright spot here. And we have a dark fringes and the brightest spot, as you see, as you go to the sides, you're getting less density. So here is central brightness for different lights, here for blue and red. And as you see, this is a single slit with wide opening. And this one is a single and narrow opening. When you have a narrow opening, you will see the pattern. Okay, when the light is coming without, the W is very big, so you just have a central brightness. All of that will pass through parallel. W is much more bigger than the lambda. But if the light is coming with the angle, so it's got, if this is theta coming with no angle, it's passed through. Okay. Rays from all part of the slit arrive at the center of the screen approximately in phase. So all of that coming here, and it will produce a central brightness. So they are in phase, that's why they add up. But let's say this is coming with the angle, so it's refracted. The wave coming from the top and the wave coming from this middle one, when they interfere, a phase change, if this is going through lambda over 2, this extra distance is moving is lambda over 2, and on the top is lambda. Basically, when they come and interference, they will be out of phase and will be destructive interference. So sine theta is equal to lambda over W is going to be dark. And here is the path difference. Here is the same thing. When this one is 3 lambda over 2, compared to here is the lambda and here is lambda over 2. The construction, the interference is going to be constructively, and they will give you bright, the bright on the screen. And for sine theta is 2 lambda over W. The interference will be, again, destructively, so it will give you dark fringe. So overall rule is this. If sine theta is equal to n lambda over W, give you minima or dark fringes, then is 1, 2, 3, and so on. And for bright, this is the formula, and make sure this is M plus 1 over 2 lambda over W. M start at 1, 2, 3, and so on. Give you a maximum. We have a maximum intensity brightness as a center. The distance, the whiteness of this bright center is the distance between your 2 minimum, which is 2 lambda over W. Here the distance between 2 successive brightness, we call it delta Y. Looking at that, since theta is a small, sine theta approximately is equal to tan, which is Y over L, opposite over adjacent. Sine theta we can approximate as Y over L. So sine theta 1 is Y1 over L. Here, sine theta 1 is Y1 over L. Also, we know that to the good approximation, so For good approximation, so we know that the sine theta is lambda over W. We had that, right? So here, for the dark fringe, when the n is 1, is lambda over W, right? Yeah, we have that here. And sine theta from geometry, we proved that is y over L. So we rearrange it for lambda. You have that lambda equal to y, W y1L. Also, since the distance between the maximum and this distance from here to here is equal from here to here, right? So basically the distance between two maximum gonna be lambda over W, or distance between two minimum will be y equal to what? Y is equal to a lambda divided by W. I can rearrange it for the delta y here as well. So look at this question. Light from a laser pointer with a wavelength, the lambda is given, passes through a slit with the width of 12 micrometers. So this is the W. The micrometer, you can convert it to the meter, multiply by 10 power negative 6. The screen is placed 30 centimeter away, so L is 0.3 centimeter. How wide is the central maximum? We know that in degree and in centimeter. In the degree, we know sine theta is lambda over W. And you rearrange it for the theta is 3.2, but here it will be half of the angle. So you need to multiply by 2. The thing is that when you're talking about how wide it is, see, it's from here to here, right? So this angle, so this is the brightness and this is, let's say, your brightness, right? What you have, you need to have this angle, which is twice of your theta, or if you find this length, it's gonna make you need to make it twice. So you multiply by 2, same thing is that in centimeter, we know that sine theta 1 is again equal to y1L. So you just rearrange it for y, so it's gonna be 1.7 centimeter, but you need to multiply it by 2, again, the same reason. Here I'm gonna show it in this picture as well. So here is the center, from here to here will be given. So you have to multiply by 2 because it's from here to here, it's twice the distance you find. That's why you multiply that by 2 here. What is the separation of adjacent minima? So, you know, that is W delta Y over L. You just rearrange it for the delta Y, and L lambda and W is given. So you find the separation between two minimum. Point.